some of our new skills and what you might have learned in another class. And we're going to try to write an equation from these applications. These are going to become two-step equations. And you can see that I've already marked out number 2 because it's really more of an inequality. So just mark out number 2. We're not going to worry about that one today. But I'm going to model for you a strategy that I would like you to start using. Again, these should become two-step equations. You might be able to figure it out without an equation, but because things are going to get more difficult, or you know, like on a quiz, you would need to use an equation since it is algebra class. So I would like you to get used to writing an equation. So I'm here to help you with that. All right. So the first thing I will say, and shh, don't tell the English teachers, but I don't always read all of the question, or I don't always read it from beginning to end. I like to start at the end so that I know what I am looking for. Because if I know what I am looking for, that allows me to know what my variable will represent. So I'm going to go to this last sentence. That's usually where I find out what I'm looking for. That says, how many CDs did he start with? So we are looking for, and I'm just going to use X. We're going to say that X is his CDs at the start. So that's how many he's starting with is X. Now that I have that out of the way, I will actually go start reading. Jason bought 6 CDs to add to his collection. So his collection is just another way of saying the CDs that he had at the start. So this is my X, and 6 is being added to that. Okay, so it looks like we got a start of an equation already. 6 plus X. Okay, that takes me through the first sentence. Then it says a week later, he dropped half. Well, half means divide by 2, right? It says his total collection. That's just reminding us that we added together the 6 and the X. Half, he dropped half of them. So we're dividing his collection by 2, and that left him 12. So what was that equal to was the 12. So now we're going to actually solve these equations, not just write them. We're going to solve them. And then we're going to try to think about if our answer is reasonable. So if I multiply both sides by 2, and I want to do that multiplication first because I have a big fraction on the left, right? The 6 and the X are in the fraction. So 6 plus X, and then because now it just out of the fraction. This would basically take us back to before he dropped them in the pond. And 12 times 2 would be 24. So if we want to know how many he started with, let's take away the 6 that he bought. I didn't leave myself space very well. And then 24 subtract 6 is 18. So I would encourage you like 18 CDs. That's how many he bought. If we got a negative number, would that make sense? I mean, some people have bad taste in music, but the number of CDs could not be negative. And CDs you can't buy half. I know you can buy individual songs, but they would not be a CD. So no. So for some extra practice with language, is a good idea to get used to putting your answer in a sentence, and I'm going to model for you how you could do that and using the question that I underlined. So the question I underlined was, how many CDs did he start with? So we could say well, if Zoom will let me. Zoom is not wanting to let me here. Maybe not. Guess I'll go back to my pencil. He started with how many CDs did he start with? He started with 18 CDs, period. So a nice complete sentence. Or you could say Jason started with 18 CDs if you want. So now let's think about if 18 makes sense in this question. Well, the question says, so if I went back to the beginning, Jason bought 6 to add to his 18, if we knew it was 18. So 6 plus 18 would make 24. If he dropped half of those 24 in the pond, so 24 divided by 2 would be 12. He would have 12 he dropped and 12 left. So our answer when we read back through the question makes sense. Okay, awesome. Right, again, we're going to skip number 2 and we're going to go to number 3 about cookies. Everybody likes cookies, right? I mean, I do. Okay. So once again, I'm going to go to the last sentence because that's usually where the question is. And what am I looking for? How many students? So my X will represent students, specifically students who turn their work in on time. But that's going to help me to know if I can find the word students, one of these numbers is going to need an X with it, right? Something has to have an X. So when I look, when I get to something about students, then I might think, this is where my X belongs. So let's just take it from the beginning. Miss Carolyn made 56 cookies, so 56. She gave, so to give to her students, but there's no number close to that student, so that doesn't really help me. She gave 3 to every student. Oh, here we go. Every or each, that helps me know where my X belongs. And she gave them. So would that be adding to the 56 cookies or taking away from the 56 cookies? Yeah, they're not giving me the cookies, I'm giving them to them. So it would be taking away. So negative 3x. So like over and over, 3 to you, 3 to you, 3 to X number of students. We're going to figure out how many. And then we read on, and I see the next number still had 8 cookies to give out later. So after this happened, the number of cookies was equal to 8. So now we're going to use this equation to find out how many students turned in their homework on time. So I'm going to subtract 56. Now I have negative 3x is negative 48. And then of course, we'll divide by negative 3 to get x is 16. Now, sometimes people, it's talking about cookies, so they have cookies on the brain and they say 16 cookies. Let's go back and read. What was the question? The question was, how many students turned in their homework on time? If I say, oh, 16 cookies. That doesn't seem to answer that question. So how many students, that's also why we write X equals students to help us remember to focus, right? So how many students turn their work in on time? I'm going to use that question to write my answer in a sentence. So I'm going to say 16 does not want to let me use the typing feature, so I guess I won't. 16 students turned homework in on time, or just turned homework in. We'll go ahead and shorten it a little bit. Or you could say 16 students turned their homework in, would be okay too. So I would like you to try number 4. Okay, I want you to try number 4. It's about a very different situation, but the equation is going to look very similar to what we did for number 3. I do want to help you get set up. It's asking for how many weeks. So X is going to be the number of weeks. And then when you're ready to write your sentence, you can say it will take some number of weeks. You could write a longer sentence, but when you get your answer, you could put it in that sentence frame. Okay, you can pause and go ahead and do that one now, or you can wait until I finish a couple more. There are going to be 2 on this page I'm going to save for you. So we're going to look at number 5 next. And once again, I'm going to start at the end. It says, find out how many hours. So how many hours, that's what I'm looking for. But specifically, it also tells me he's only going to work 1 day and he needs to earn $68. So, but hours is the X. So when I look at my numbers, I see he gets 20 and he gets 8 for every hour. So 8 is going to get the X because X, we're looking for hours. And then this is how much we wanted to add up to. So he receives 20 plus $8 an hour. So 20 just for showing up, I guess. That's what they mean by base pay, is just for showing up. And then is equal to 68. And then we again have a 2-step equation. And if you want to go ahead and try it on your own, pause me and then come back to see if we did the same thing. Hopefully you don't catch me making a mistake. But it happens even to teachers. 68 subtract 20, 48. And then we're going to divide both sides by 8 to get X is equal to 6. Okay, so just saying X is equal to 6 doesn't tell me a lot. So how many hours he needs to work in 1 day? So he needs to work 6 hours. I want to make sure we don't say something like he needs to work 6 days. So he needs to work 6 hours. We could say 6 hours in one day. We could say James needs to work 6 hours. We have more than one way we could say it. So notice I used he needs to work from the question, and then I included our answer and included that those are hours, not minutes, not days, not months, years, etc. And then I would like you to try number 6. Very good. I hope this was helpful. Again, how many months? So let your X equal months. That step where we say X equal some, like what it stands for, that is called defining our variable. It's just saying, what does our variable represent, to help us get our bearings in our problem, to help us have an idea of where are we starting at. Okay, great. Thank you so much.